Alright, our next set of trends are trends in electronegativity and ionization energy. So electronegativity is an atom's tendency to attract electrons when it's trying to combine with another element. Noble gases do not have an electronegativity. They don't readily form compounds. Remember we said they don't want to be with anyone else. They have their octet. They don't want to share their electrons. They don't want to take anyone else's. So noble gases do not have an electronegativity. Electronegativity is going to generally decrease as you move down a group, and it's going to increase as you move left to right across a period. The exception here is going to be the transition metals. They don't really have a regular trend. So as we move down a group, the desire for other electrons is going to decrease, and as we move left to right, that desire for other electrons is going to increase. So your most electronegative element is fluorine, and when fluorine bonds with another atom, it attracts their electrons. So fluorine has 7 valence electrons, 1, 2, 3, 4, 5, 6, 7, which means it has this free spot here. Okay, it wants to fill that free spot. So somebody with 1 valence electron, like sodium, is going to be attracted to this free spot so that they can make a bond. Your least electronegative elements are francium and cesium, and when those guys bond with another atom, they're going to be attracted to those electrons. So if you have francium and chlorine, francium is going to have its 1 valence electron, chlorine is going to have its 7. So chlorine is going to have this empty spot right here. Fluorine is going to be attracted to it. They're going to come together and they're going to make a bond. So as you move left to right across the periodic table, electronegativity is going to increase going left to right, and going top to bottom it's going to decrease. These guys have a lower electronegativity. These guys have the highest electronegativity. So this brings us to ionization energy, and ionization is the formation of an ion, so it's going to be gaining or losing electrons. And ionization energy is the energy required to remove an electron from a neutral atom. Electron affinity is the energy that is released when an atom gains someone else's electron. So ionization energy will generally decrease as you move down a group. Due to the bigger size, those outermost electrons are going to be very easy to remove. There's not as much attraction to the nucleus there, so it's going to be very easy to pluck those outermost electrons off. But as you move left to right, remember our atoms are getting smaller. There's going to be more attraction to those protons in the nucleus, and that's going to make it very difficult to remove those outermost electrons further to the right on the periodic table. Again, this is going to exclude the transition metals going left to right. Those guys follow their own rules. So going left to right across the periodic table, the ionization energy is going to increase. It's going to become very difficult to remove the electrons, well, not from that one, from these guys, okay? It's going to become very difficult to remove these electrons. Whereas these guys, it's going to be pretty easy to pluck them off. They're large, there's not high attraction there, so it's going to take less energy. So as you go top to bottom, your ionization energy is going to decrease.